everyone. I, Dr. Anju Dikshit, Deputy Director, School of Basic Sciences, CSGM University, Kanpur. Delighted to warmly welcome you all in the inaugural session of the National Workshop on Data Science and Machine Learning. But before we begin, I would like to extend my gratitude to our Honorable Vice Chancellor, Sir, Professor Vinay Kumar Pathak, who constantly motivates us to engage in academic pursuits. Also, I extend my heartfelt thanks to the Director School of Basic Sciences, Professor R.K. Dwivedi, and Director School of Engineering, Dr. Vishti Mitra, for their continuous support and guidance. It is my pleasure to welcome all the distinguished speakers, faculty members, and the participants in the National Workshop on Data Science and Machine Learning. Definitely, this workshop will be fruitful for the participants and it will enhance their knowledge in the area of data science and machine learning. Now I am inviting convener of this workshop, Dr. Namita Tiwari, to brief more about National Workshop on Data Science and Machine Learning. Namita, please.
Thank you, ma'am, for such motivational words. Good morning to all dignitaries, guests, and delegates. I, Dr. Namita Tiwari, feel privileged to extend my warm welcome to all presented over here for the inauguration of 5 days National Workshop on Data Science and Machine Learning, NWDSML 2022, organized by Department of Mathematics, School of Basic Sciences, UIET, Chhatrapati Sahuji Maharaj University, Kanpur. First, I would like to convey my sincere thanks to our Honorable Vice Chancellor, sir, for his inspiration and encouragement. I am also thankful to our Director, School of Basic Sciences, Professor R.K. Dwivedi, sir, Director, UIT, Dr. Vishti Mitra, ma'am, and Deputy Director, Dr. Anju Dikshit, ma'am, for their constant support. We believe in learning by doing. So we have designed the workshop NWDSML 2022, which includes concept building, expert lectures, the hands-on sessions and quizzes as well, to make the participants learn the concept by applying in real-world problems. According to Clive Humvee, data is the new oil. It's valuable, but if unrefined, it cannot really be used. It has to be changed into gas, plastic, chemicals, etc. to create a valuable entity that drives profitable activity. So, must data be broken down, analyzed for it to have value? By now, you must have understood the importance of data processing. And that is where we take help of data science techniques to convert data into information. Data science enables companies to efficiently understand gigantic data from multiple sources and derive valuable insights to make smarter data-driven decisions. I would like to quote famous lines by Benjamin Franklin. Tell me and I forget, teach me and I may remember, involve me and I learn. So with this wonderful note, now I request Director UIT Dr. Vishti ma'am to address us all on this occasion.
Thank you, Namita, and thank you, Anju. It's indeed a great pleasure to be a part of this inaugural ceremony. And thanks to our Vice Chancellor, sir, who's always encouraging all of us to organize new workshops, conferences, seminars, etc. I'm grateful to him for giving all of us the opportunity to do it. Dr. Rajesh Kumar Dwivedi, Director, School of Basic Sciences, Dr. Anju Dikshit, Assistant Director, School of Basic Sciences, all the distinguished speakers of this workshop, the members of the organizing committee, and all the faculty members and other participants. I indeed congratulate your department for organizing this today. Now, data science, artificial intelligence, and machine learning are all buzzwords in the present times, as has been mentioned. They find applications in all factions of our life and all branches of engineering in the present day. So familiarity with these fields and decision-making based on the analysis of data is kind of the need of the hour. Data science is the field of study that aims to use scientific approaches to extract meaning and insights from data, and hence we can make meaningful deductions or conclusions from this. Machine learning, on the other hand, refers to the groups of techniques used by data scientists to allow computers to learn from them. In our engineering school, we have several courses that we teach to our engineering students, which involve both data science and artificial intelligence, machine learning, all of these. And now we have plans of introducing to this to all our students of different branches too. It's wonderful to see the mathematics department doing something about it, so that this knowledge can be spread all over. So during this 5-day workshop, I see that the participants will have the opportunity to hear and learn from very experienced faculty members from IIT Kanpur, from MNNIT Allahabad, University of Technology Sydney, and also from members of the industry. I am also pleased to know that there will be hand-on sessions conducted along with the lectures in this workshop. This was enable us or each of these participants to better understand the concepts. I hope all participants will make best use of this learning experience, and I congratulate the Department of Mathematics, CSJMU, for organizing this workshop and wish them all the best for a successful completion of this event. Thank you very much.
Thank you so much, ma'am, for your enlightened words. Now I request our Director, School of Basic Sciences, Professor R.K. Trivedi, sir, to encourage us with his valuable words. So please. So please unmute yourself.
Sorry. Thank you, Namita ji. A very good morning to you all. I think you can hear me now.
Thank you, sir.
Honorable keynote speaker of inaugural session, Dr. Saswati Banerjee, Dr. Rajdeep B, Director of UIET, Professor Vrasti Mitra, learned faculty members of School of Basic Sciences, my dear participants and friends. First of all, I take this great opportunity to welcome you all to this inaugural session of National Workshop of Data Science and Machine Learning, which is being organized by our Department of Mathematics, School of Basic Sciences from today till 19th of July 2022. Friends, as has been said by all of us, machine learning, artificial intelligence, data science, Internet of Things have emerged as new fields in the recent years. Today, it is becoming a necessity for all of us to learn them. I am happy to see that our colleagues from Department of Mathematics, School of Basic Sciences are going to organize this 5 days workshop by inviting experts to enrich our students and faculty members. I extend my best wishes to the success of the workshop. Thank you very much.
Okay. Thank you very much, sir, for your valuable words. Now, on this auspicious occasion, it is proud privilege to invite our chief guest, Honorable Vice Chancellor Professor Vinay Kumar Pathak, sir, to incite us with his inspirational thoughts.
Namita, did you remind our Vice Chancellor to join the meeting at 10?
Yes, sir.
So any message from his side?
Okay. So the participants will join after some time. So we are going to start the session. So to accomplish great things, we must not only act but also dream, not only plan but also believe. With these lines, I request Dr. D.K. Singh, Coordinator, Department of Mathematics, to extend and chair the technical session. So please.
Good morning, ma'am. So, our first speaker is Dr. Saraswati Banerjee. So, Dr. Saraswati Banerjee is the Assistant Professor in the Department of Computer Science and Engineering, Motilal Nehru National Institute of Technology, Allahabad, Prayagraj. She has completed PhD from MNIT Allahabad. Dr. Saraswati research interest in the Internet of Things, software-defined networks, information security, artificial intelligence. She is also member of IEEE, ACM, CSI. She has received the Best Participation Award in 2016 for her research paper, Implementation of a MapReduce Overstructured Peer-to-Peer Overlay of Underutilized Resources. I request to Dr. Shashwati overwhelm the participant with their knowledge. Madam, please.
Thank you very much for the introduction, sir. Is this audible? Is the voice audible, sir? Can anybody from the audience tell me whether I'm audible or not?
Yes, ma'am.
Yes, ma'am.
Okay, okay,
Yes,
okay.
ma'am.
Yeah, okay. Thank you very much. Okay. So let me begin then. Right now trying to share my slide.
Hello. Hello.
Yeah, please tell me. Okay. Is this visible?
Yes, ma'am.
Yes, ma'am.
Okay,
We are
okay.
able
Thank
to
you. So
see your
I
PPT.
thank the organizing committee for inviting me
Yes,
as
sir.
the
Your voice is
speaker.
coming, madam.
And indeed, I
Yeah.
feel this to be a privilege to talking to students, to the
Madam, your
audience.
voice
Okay.
is low. So,
Voice is low? Okay. Okay, so I assume that everything is on
yes,
the
yes.
right track. I mean, the voice, the slides, everything is visible. Okay. So let me start with. Okay. So, neural network is a very basic thing that we talk about in machine learning. Right. So, this is the basis for going into much details of deep learning models, fine, the different classification and prediction models. Okay, so basically let us say I'll start with a very small example. Okay, so suppose that we have the dosage of a medicine. Okay, and the depending on the dosage we have to understand or we have to predict whether this dosage will be fruitful or beneficial to the person whom this is given or not. Fine. So there are three different stages. Basically, you can have a low dosage of medicine, you can have high dosage, medium dosage, etc. Fine. And then we are going to draw a function which is predicting the efficacy of the drug. Okay, so what happens here is we are given the input, which is the dosage over here, and we have to find out the function that given the dosage, we have to predict whether this dosage will be beneficial to the given person or not. Fine. So there are different algorithms which can be used for this kind of prediction. You must have heard about the different algorithms as well. Today we will be talking about how an artificial neural network model can be trained so that it can, given the input dosage, it is able to predict the efficacy of the drug. Able to understand this? Okay. So basically, you must be having this brief idea also. Basically, this consists of a set of nodes, as you can see these rectangular boxes, fine, and the connection between these nodes, the arrows that you can, the black arrows that you can see over here. Okay, so we have input nodes, right? Then we have the output node, which is going to give us the final result. And in between the input and the output node, there can be one hidden layer or there can be n number of hidden layers. Now, this hidden layer is going to update itself. We will be talking shortly about the weights and biases. Okay. And this hidden layer is kind of hidden treasure for us. Okay. So these hidden layers get trained, and given the input, once the input is supplied to the hidden layers, okay, through the input layer, it predicts the output. Fine. So basically what happens is there are certain weights, okay, W1, W2, W3, W4, W5, etc., etc., depending on the number of hidden layers that we have and the number of nodes in the hidden layer. Okay, so basically we start with unknown parameters and then finally we estimate these unknown parameters so as to get the output curve. Able to understand this? The goal is to find out this function. This curve, this is nothing but a function of dosage. Able to understand this, right? So how do we actually begin with? Basically, we are giving the input dosage over here. Okay, we are multiplying the weight, adding the bias, and passing this through an activation function. If you look at this figure here, okay, so basically what we are going to do over here is you have the dosage, input dosage. You multiply this dosage with the weight. You add some value of bias. Okay, this acts as the x-axis. This value is going to act as x-axis for this particular function, which we call as the activation function. Okay, let me use the pen. Okay, so this value, okay, this acts as the x-axis value for this activation function. This function is called as activation function. Now once you get the y value of this corresponding to this x value, you again multiply it with this weight. Okay, this is called as weight. All these are called as weights. Okay, and this value is called as bias. Okay, now finally, so this input value, whatsoever value of dosage you are going to supply over here, goes through this particular top node, you can say, and then similar process is repeated for this bottom layer as well. Finally, we add the final bias and then we get the output. There is again some functionality which we called as softmax layer, which is involved over here, but let us not talk about the softmax layer right now. We add the bias and then we get the output. Okay, so a very small thing we will sail through. Okay, here we are going to supply the input dosage. This is what is being shown to us with the help of an example. Okay, this is what we get as the curve. Which curve is this? This is the output of this curve. This curve. You can say this is the first curve. Similarly, dosage supplied over here. Okay, bias, we add the bias value. We get the x-axis for this. Okay, and then we get the corresponding y value. You multiply again with the weight and then you get the second curve. All right, now you put different values of the dosage and you get different values for the curve, like the one which has been shown over here. So you change the value of dosage, you get different values for the efficacy, right? Then what happens? Similarly, for the second, like the bottom node in the hidden layer, you put on the values and you get this curve. Okay. From both the curves, you add up this sum, which is the final bias, and you get the output here. Okay, this is the new resultant curve. This is what actually happens in a neural network. This is the basic functionality, basic understanding of a neural network. Now, there are various concepts which are involved in the learning of a neural network. Okay, which are involved in the learning of a neural network. What are these things? The first thing is your chain rule. Okay, the second thing is your gradient descent. Okay, so basically what happens is, if you remember in the first slide, what we are trying to talk about is we have got different weights and we have got different biases which need to be found out. Able to understand this? So how do we find these optimized values? That is what is the aim of an artificial neural network. Able to understand this? You have to find out the correct values of weights and biases. Okay, so now how do you go about it? So the first concept which is required is your chain rule. Okay, then the next thing is your gradient descent. So you optimize these values using gradient descent. Okay, so before we can understand gradient descent, it is important to know what is the chain rule. Okay, let us suppose, I believe the students of mathematics would be able to understand this in a better way. Okay, so suppose we have collected the weight and height measurement of different individuals. Okay, so given the weight, you have the corresponding height. Okay, now basically you can use this green line to find out the weight, to find out the height if the weight is given to you. Okay, so if you try to find out the slope of this line, basically if you increase the weight by 1, you can see from this graph that the height increases by 2. Able to understand this? So you can very well say that the slope of the line, which is y2 minus y1 upon x2 minus x1, this is basically 2. Okay, so slope becomes d of height, d by, like weight is differentiated, derived out of the height. So the equation of height becomes the equation of the line, which is slope into this x value, which is weight. Intercept is 0, so there is no point of adding the intercept over here. Okay, now the next situation is you have the height of the person and you want to find out the size of the shoe of the person. There is a relationship between the height and the shoe size. Okay, now we fit this line. Okay, we have a data and we have found out that, okay, this line is going to fit into this data. Okay, so given the height, we are able to find out the shoe size. Okay, now if you try to find out the relationship between the weight, height and shoe size, basically the relationship between weight and shoe size will you be able to find it?
No, ma'am.
Why? You are given the height, you are given the weight, okay, and you are supposed to find out the shoe size. Okay, so basically, if you want to see, you have been given this weight. So from this weight, you can find out the height. Okay, and from this height, if you place it over here, you get the shoe size. Okay, so basically, see, if you try to find out the relationship between height and shoe size, okay, so basically what happens is the same formula that we have used for weight and height. Okay, so this change would be like, if you want to find out the shoe size, it is nothing but the slope into height. And what is the slope? Slope is change in y with respect to x. Okay, so this is basically d of size upon d of height. Okay, so this becomes your shoe size. Now, weight can be predicted from the height and shoe size. Okay, weight is related to height and height is related to shoe size. So we can derive a relation between the shoe size and weight. How? Shoe size is what? It is basically d of size. Shoe size, how are you going to calculate this? Shoe size. Look at this equation. This is shoe size is equal to slope, which is d of size upon d of height, okay, into your height. In place of height, what you can put is, because height is what? It is slope into weight. Able to understand this? So basically, the chain rule says that if you have an intermediate variable in between, then you can find out the rate of change of shoe size with respect to weight using the chain. Okay, so basically, d of size with respect to weight is d of size with respect to height into d of height with respect to weight. Okay. Now, where do we use? Is the chain rule clear? Okay, no response means that it is clear to everybody, I suppose, I assume. Fine. Now, where are we going to use the chain rule? Basically, in case of a neural network, what happens is we find out the optimal value of weights and biases. Fine. Weights and biases are called as parameters. Okay, weights and biases are called as parameters. Okay, so we try to find the optimal value of parameter. How will we find out the optimal value of parameter? Let us go back to this original slide from where we started. See, you have to find out the optimal value of these parameters. So how does this neural network training begins with is, you initially put on some random value for the parameters. You initially put some random value of parameters. All right. Then you find out that difference. What kind of difference? This is the observed output. Okay. This is a supervised classification, mind you. Artificial neural network is supervised type of classification wherein the labels or the output labels are already given to you. Are you able to understand? That means you initially have a CSV file or a table or an image where you already know during the training that if these are the values of input, this would be the output. Supervised learning, how does this work? Say, for example, we have features, let us say x1, x2, x3, up to xn feature values we have. Okay, now this is sample S1, this is S2, this is S3, up to let us say SZ. Okay, these are the different values for the features. Okay, now if these are the feature values, you know that this is going to be the output. Let us say if this is an let us suppose this is an image value. Okay, so this will be 0, 1, 1, 0, things like this, and the output image is that of a cat. Okay, so this labeling is already given to us a priori. Okay, now you have the observed value, and then this is the predicted value that has been found out after running through this neural network and putting on the values of weights and parameters. We initially start with the random value. Okay, now these random values, you run this neural network train the neural network, and you find out the value of the predicted value. You find out the difference. Okay, observed is, let us say for example 5.7, and predicted you are getting is 2.3. So you find out the difference between these, and then you again change the value of the parameters. This is the crux of a neural network. Able to understand this? Okay, so now how are you going to find out what is the by how much shall you change the value of the weights and biases? Okay, that is dictated by your gradient descent algorithm. Okay, now gradient descent algorithm in turn is dependent on how are you going to find out the value of the gradient descent, like how are you going to work upon the gradient descent. That is dictated by the chain rule. Fine. So let us take this example. Yeah, suppose that we have measured someone's height and weight. Okay, you have been given a sample. Okay, sample is what? You are given the weight. Okay, and you are given the height. Okay, let us say for example you have 1,000 or let us say 10,000 samples like this. If this is the weight, this would be the height. This is the weight, this would be height. This is your input file which will be used for training. Okay, which will be used for training. Fine. Now what you have to do is you have to fit this green line so that after you train this model, like you find out this green line, and if you are given a weight, this green line is able to predict what would be the height. Able to understand this? So now what needs to be done is you have to find out the intercept and slope of this line. Remember, the equation of line is y is equals to mx plus c. So x is the weight that will be given to you. You have to find out the optimal value of m and optimal value of c. Simple thing. Okay, so how do you begin with? You initially start with some random value to make the things simple. In this particular example, okay, we have already taken the slope, okay, and we just want to find out the intercept of the line just to keep the things simple. Okay, so how are you going to start with is you're going to start with some random value of the intercept. Okay, and then you find out what is the difference between the observed and the predicted value. Okay, now that value, this observed minus predicted, this could be negative sometimes. So it is always better to take the square of this value. Okay, now what you are going to do is you are going to plot this value. Okay, you are going to plot this value over this residual. Okay, so this, as you can see, this is the observed height, actual height. This is given the weight. Okay, and this difference is going to give me the residual. Okay, fine. And then you're going to move this line in this direction. You cannot see the example that I have taken over here is for making the things very simple. I've just considered one point. Okay, while painting this line, you will be considering so many 10,000, 10 million points so as to fit this line onto the data. Able to understand this, right? So now, based on this difference, we are going to shift this line either upwards or downwards, right? So what we will do is we will be calculating the sum of squared residuals, and we are going to find out the change in the intercept with respect to squared residuals. Able to understand this? Okay, so this is your intercept and this is the value of the residual. Okay, जैसे like once you change the value of the intercept, the residual is obviously going to change. Fine. If you move the intercept here, okay, let us say this intercept is 1. Okay, now if you change the value of intercept, make it 0.5, obviously the value of the height would change. Okay, once you make this 0.25, okay, this y value would again change. Able to understand this? So you have to find out the optimal value of this intercept so that if you are given the weight, you can predict the height. Like you, in the sense, the line is going to predict the height. Okay, so this is your residual and this is the squared residual. Able to understand this? Now, in order to find the value of intercept that minimizes the squared residual, okay, what you have to find out is, so what you get is, this is your residual and this is your squared residual. Okay, you are going to get this curve, let us say. Okay, so we have to find out the value for the intercept where the squared residual is minimum. Okay, how will you find this out? Squared residual is minimum. That means the rate of change, once you change the intercept, the reflection on the squared residual is minimum. Is this clear to everybody? Once you change the intercept, the value of residual will change. Okay, you have to find the optimal value of the intercept where the residual is minimum. Okay, so rate of change of squared residual with respect to the intercept. Is this clear? Okay, so basically squared residual, rate of change of squared residual with respect to intercept is squared residual, rate of change of squared residual with respect to residual and with respect to intercept. Fine. So if you differentiate this residual square upon residual, you get what? 2 into residual by the rule of derivation. Okay. And d of residual with respect to d of intercept is what? Residual is what? Difference in the observed and predicted value. Okay. Now predicted value is what? Predicted value is your intercept plus 1 into weight. Remember, you have taken the slope to be equal to 1. Okay. Now, once you derive this, you get the value of minus 1. You put in the value of weight. Okay. And then you calculate this. This is the output. Okay. Now, if you find out the value, so this becomes the value of the intercept such that residual square is equals to 0. You put the observed weight and height, you get the value of intercept to be equal to 1. Okay. What will gradient descent do is, you have the option of using a sum of squared residuals, okay, to find out the best value for intercept and slope, right? But then what you have to do is, there is a lot of work. How lot of work? Because every time you will have to put the value for, yeah, you have to put the value for the intercept and calculate the sum of squared residual every time, right? So now, how will you understand what is the best value for the intercept? Whether this value would be the best, where the different, like the rate of change of squared residual is minimum, or it lies somewhere between this point and this point, or in between this point and this point. So the sum of least squares method is efficient, but at the same time it is very, very time taking. Okay, what gradient descent does is, gradient descent is going to take big steps when the difference is large. Okay, let us say, for example, if you look at this graph, so this is the value of sum of squared residuals when the intercept is 0. Okay, this is the value when the intercept is 1, when the intercept is 2. Okay, so it is going to take big steps when the sum of squared residuals is large, and it is going to take very, very small steps when the intercept, when the optimal value is neutral. Okay, how it is going to do this, we will see. Okay, so pick a random value for the intercept. Okay, substitute it in the equation. Okay, so predicted height, like what we did in sum of least squares method. So basically, you assume that the slope is 0.64. For simplicity, we have taken this, and then you find out the difference in the observed and predicted. Okay, so basically, you start with some random value of the intercept. Okay, then you put on the value of the weight, and then you get a value of the height. Okay, now what will happen is, say for example, the example that they have taken is, this is the value of the weight and this is the value of the height. Okay, so initially what we begin with the intercept value to be equal to 0. Okay, this value of slope we have already assumed. Let us say this is the optimal value. Okay, and you put in the value of width. Yeah, please tell me. Okay, you get the predicted height. Okay, now what happens is, the observed height, however, is 1.4. This is the correct value of the height. But what we are getting over here is 0.32. So that means there is a difference in the observed height and the predicted height. Okay, so this is what we get as the residual. Fine. Similarly, if you look at this, we have taken 3 examples, 3 data points, just 3 data points. Okay, there would be millions of data points if we wish to train a neural network. Okay, so if you similarly consider the second and the third data point, okay, so we get the residuals like this. Okay, then you find out the sum of squared residuals over here, and you find out that if you have the intercept value as 0, what would be the sum of squared residual? If you have the intercept value of 1, what is the sum of squared residual? Intercept value 2, 3, etc., etc. What is the sum of squared residuals? Okay, now it will do a few calculations. Okay, when the optimal solution is far away, and increases the number of calculations when it is close to the optimal value. Okay, right? This is the sum of squared residual equation that you are going to get. Okay, and assuming the intercept to be 0, okay, what we will do is, once this intercept value is 0, we are going to get the d of sum of squared residuals is minus of 5.7. Okay, the next step is, the magic of this gradient descent algorithm is, now we are going to use this value to calculate a learning rate. Able to understand this? Okay, so now this learning rate is what? This is the slope into the learning rate. Okay, we are going to calculate a step size. Okay, step size is what? Slope into the learning rate. Basically, while we were doing the sum of squared residuals or the least square method, what we were doing was, we were calculating the sum of squared residuals. Okay, and then plotting this. Okay, and finding out the let us do this. Okay, if we have the least square method, fine. So least square method, what it is going to do is, you have the value of intercept to be 0. This is what is the value of sum of squared residual. Fine. Now you change the value of intercept, make it 0.5. This becomes the sum of squared residual. Okay, then again you change the value of intercept, make this 0.25. You're going to get the sum of squared residuals. Okay, basically you are going to change the value of intercept without knowing by how much you should change the value of intercept. Whether you should take small steps or you should take a very big leap, that was not clear at that point. Able to understand this, whether you should, the first is 0, if the value of first intercept is 0, whether the next should be 0.5 or 0.4 or 0.3 or 0.25, that was not clear. Able to understand this, so that was taking too much of the calculation. Here, in case of gradient descent, what we will do is, we have a step size. This step size will be affecting our learning rate. Able to understand this? Okay, now step size is a function of the slope, or step size is a function of, step size is a function of the rate of change. Able to understand this? What was the rate of change that we got? Rate of change is your d of sum of squared residuals upon d of intercept value. Okay, in place of sum of squared residuals, you can consider any other loss function as well. Okay, there are so many other loss functions also that are going to tell us the difference in the residual, that is going to tell us the difference between the observed and the predicted value. Okay, so this slope into learning rate. Now, what should be the value of learning rate? Okay, we take some default value. Okay, but learning rate is something that is not a part of discussion in the gradient descent. Okay, this value is already assumed to be 0.1. Based on some experiments, you can find it out whether this learning rate is suitable or not. Okay, and then once you calculate the step size, you are going to calculate the value of new intercept. Okay, now new intercept is what? The old intercept minus the step size. Okay, old intercept, initially we started with the value of intercept to be 0. Okay, we calculated the step size to be minus 0.57. We get the new value of intercept. Okay, we get the new value of the intercept. Now what we will do is, we will put the new value of the intercept. Okay, new value of the intercept over here. Okay, in this equation, and then calculate what is the value of the, like what is the, I'm sorry. Yeah, what is the difference that we are getting. Okay, that would be put in the value of the slope. Okay, and find it out. Yeah. Okay, so this is the new intercept value. Okay, put this new intercept value in the sum of squared residual equation, you get a different value for the slope. Okay, initially it was minus 5.7, if you can understand. Yeah, minus 5.7. Now it is minus 2.3. Okay, then you again calculate the step size, okay, and the new value of the intercept. Okay,
Ma'am, how we know about the learning rate?
learning rate learning rate is something which is calculated through the experiments. By default we take it as 0.1. Okay, in some of the experiments also 0.1 is not sufficient, so we take 0.01. so that is beyond the scope of discussion of gradient descent. Basically, gradient descent focuses on optimizing the value of the parameters. Okay, so parameter here is one is your weight and the other is your bias. Able to understand this? In this case, what we are trying to find out is the value of the intercept and the value of slope. Okay.
Okay, ma'am.
Yeah. Okay. Any other question? Okay. So it will be repeating this process, like till how much value are you going to calculate back and forth. So that depends when the step size is close to 0. How are we calculating the step size? Step size is basically slope into learning rate. Okay, slope, how are you going to calculate? Slope is basically the differentiation of loss function over the parameter value. In case of, in our case, the parameter is nothing but intercept, and loss function is what? Sum of squared residual in our case. Okay. Fine. So either the step size is close to 0 or the maximum number of steps is exceeding 1000 or greater. Okay, so basically at a glance you can see what we do is we have got, if you look at this algorithm from the weight and height example, is you have got 10,000 input samples, okay, that act as your training set. Okay, we are training this model. Always understand this, that we are training this model to find out the optimal value of parameters. Okay, in this particular example that we have considered, the parameter is intercept and slope. For the case of simplicity, we have assumed that slope is already optimized. Slope is already optimized and we have fixed this value to be equal to 0.64. Intercept value, we are trying to find it out. Okay, so obviously we have to find out the value of intercept such that the loss function is equal to 0. How will you find out that value of intercept? That means if you change the intercept, the change in loss function should be equivalent to 0. So how do you calculate change? Obviously, d by d of intercept with respect to loss function. Okay, loss function in this case was sum of squared residuals. Okay, sum of squared residuals means that you find out the residual. Residual is what? The difference in the actual value and the one that you are getting while experimenting with the value of intercept. Able to understand this? You're going to take the square of this residual so that the value is not going to be negative. Okay, then what you do is you have put in some value of intercept, initial random value. You can start with 0, you can start with 5, you can start with 10, your choice. Then you are going to get some difference because of the actual and predicted, because you are optimizing the value of this intercept. So obviously you are going to get some difference, right? And then once you get the difference, you calculate the step size. This step size is going to help you understand whether you should leap from intercept value of 0 to directly 0.5, or you should go from 0 to 1, assuming that 0 is the initial random value of intercept. Able to understand this? Fine. And then you will be revising the value of the new parameter on the basis of the old parameter and the step size that you have calculated. We will be repeating this entire process. That means you will be putting in new parameter value into this B of loss function and intercept, and you will be again getting a step size. We will be repeating this until the step size is, let us say, 0.001, or you have exceeded 1000 steps. This is the algorithm of gradient descent. Okay, questions into this? Any question that the audience wish to ask?
Audience, any question? Participants? मैडम मेरा एक क्वेश्चन है कि न्यूरल जो प्रॉब्लम्स है कैन वी सॉल्व विद द मैथमेटिकल मॉडलिंग आल्सो?
Sorry, come again. I could not hear the question. Can you please come again, sir?
Okay. Can we apply mathematical modeling to solve the neural problems?
Yes,
Can we get
obviously.
some ideas about these things?
Mathematical.
Personal question. Because I get some differential equations here, that's why I'm asking to you this question.
Yeah, sir. So what do you mean by the mathematical modeling? Like in what terms you're looking for it?
Okay, ma'am. Myself, Dr. Izharuddin. May I ask one question?
Yeah, sir. Please.
Yeah, myself, Dr. Izhar from Mathematics, Department of Mathematics, Jamia Millia Islamia. So, if I wish to do some research problems on neural network via convex optimization or fixed point theory, so what computational tool I should collect? Because my background is purely mathematics, but I am seeking the application of fixed point theory, particularly in neural networks. So, what computational tools should I know?
Sir, there are multiple tools available. One is your MATLAB, which people use very frequently.
Ma'am, I'm not talking about the software. I am well aware about software like Mathematica, MATLAB. I myself know. I know Python also a little bit. But I'm asking what computational science I should know.
computational science.
Yeah, means what computer knowledge I should know, because I don't have any knowledge of computer or computer I don't have any insight of the computational science except some particular use of Mathematica, MATLAB. This anyone can do, not only mathematics or computer science. Even nowadays, economics students also use Mathematica and MATLAB. So no, this is not a special computational tools, I believe. So why should I know that? For because if your way of presentation was really nice, you have and least square method. I see that I am really inspired by your presentation on least square method. Also, calculation of the step descent, because these are the very popular models in neural networks.
Mhm. So, sir, background computational knowledge, if you talk about, so basically what generally people do is this usage of this MATLAB, like you said, usage of this MATLAB and Python does not require any special computational skills. You are absolutely right. You do not need any kind of special computational skills for this, because we already have very rich libraries, if you see, in Python or in MATLAB, and you can very well use those functions and you can go ahead with your problem.
Okay,
So,
thank you very much for your nice presentation as well as nice explanation. Thank you.
thank you, sir. Thank you very much. Yeah.
Thank you very much, ma'am, for your valuable speech and for giving us
Thank you.
your speeches. Time for us, madam. Thank you. Thank you.
Thank you, sir. So, shall I leave now?
Dear participants, BC sir will be joins very shortly, so please just stay here.
Sorry, sir.
Hello, good morning, ma'am. Once again.
Good morning, sir.
Yeah, can you share your email ID so that we can ask some particular problem and send some research problem to you so that you can help?
Okay, sir. So, shall I write it down on the chat box?
Yeah, it's better.
Okay. Just a second. Let me see.
Thank you very much, ma'am, for your valuable words and valuable speech. Again, for giving us your precious time for us, madam. Thank you. Thank you very much.
Okay, sir. Thank you. It was indeed a pleasure to me as well. I would have loved it if the audience would have put in more questions. So that would have been really nice. But anyways, they can always drop me a mail at. I have mentioned my mail ID on the chat as well. So that is that. Okay, sir. Thank you very much. So I'm leaving then.
Have a good day.
Thank you. Yeah. Okay, sir. Thank you. Yeah. Any question? Okay. Thank you very much.
अभी नहीं आया तारे भाई देते हैं ओके तो मैं जो हूँ एग्जामिनेशन में अकमल रफीक साहब को मैंने कॉल की मगर उन्होंने नहीं उठाई काजमी भी जो है काफी कॉल और वो लेकिन जो है नहीं उठा पा रहे हैं लोग तो मैं खुद जा रहा हूँ और इसको काम को मैं कराता हूँ
Dear participant, please just stay here. BC sir will join shortly.
Very good morning. On this auspicious occasion, it is proud privilege to invite our chief guest, Honorable Vice Chancellor Professor Vinay Kumar Pathak sir, to incite us with his inspirational thoughts. So please. I think there is a network issue. So on the auspicious occasion, it is proud privilege to invite our chief guest, Honorable Vice Chancellor Sir Professor Vinay Kumar Pathak, to incite us with his inspirational thoughts. So please, I'm audible.
Yes, you are audible. आवाज आ रही है मैम? हेलो, आवाज आ रही है? आवाज आ रही है? अच्छा ठीक ठीक नहीं इधर की तो आएगी, मैं चेक कर रहा हूँ। मैडम बोले, आप बोलिए उधर, आप बोलिए उससे। हाँ ठीक ठीक।
So on this auspicious occasion, it is proud privilege to invite our chief guest, Honorable Vice Chancellor Sir Professor Vinay Kumar Pathak, to incite us with his inspirational thoughts. Hello, I'm audible.
Yes, ma'am, you are audible.
Okay. So, good morning, all.
Good morning, ma'am.
Very good
On this
morning.
auspicious occasion, it is proud privilege to invite our chief guest, Honorable Vice Chancellor Professor Vinay Kumar Pathak, to incite us with his inspirational thoughts.
Hello. Hello, Ita. Am I audible, Ita?
Yes, ma'am.
Okay, fine, fine.
After that, will we start your lecture, madam?
Yeah, pardon, please.
Ma'am, we are waiting for our Vice Chancellor, sir.
Okay.
After her valuable words, will we start your lecture, madam?
Yeah.
So, please.
Yeah, sure. I'll be online. I just wanted to check whether my mic is audible or not. Okay.
Okay. Thank you, ma'am. Thank you very much.
Okay.
Hello. Hello. Good morning, all. I'm audible.
Yes, ma'am.
Yes, ma'am.
Ma'am, you are audible.
Echo आएगा।
कह रहे आवाज नहीं आ रही। हेलो, हाँ भैया, आवाज यहाँ तो सब बता रहे आवाज आ रही। मोबाइल से करवा रहे हैं, मोबाइल से इको आएगा। अच्छा, मोबाइल से
Good morning.
अब आ रही है आवाज? अब आ रही है? अभी नहीं आई? अब आई आवाज? अब आई।
Hello.
ठीक है भैया, अभी स्टार्ट करा। अच्छा, तो सर का वेट ही कर लेते हैं स्पीकर के। हाँ, वेट कर लेते हैं। अच्छा, स्क्रीन पे दिख रहा है तो सब आते हैं अंदर, फिर के आते हैं तभी स्टार्ट करेंगे। हाँ, ठीक है, हम वेट कर लेते हैं। ठीक है। अच्छा, ठीक है। प्लीज सर, यहाँ पे दिखने लगे आपको ना, तब सबका स्टार्ट कर दीजिएगा। किसी को बोलना है वीडियो तो बोल दीजिए, उसको क्या बुलवा दें वीडियो 2-4 मिनट के लिए, क्या बोलेगा? मेरा वहीं पे खड़े हो, आपको वहाँ आवाज आ रही है ना, जैसे यहाँ से दिखे ना, इशारा करके स्टार्ट कर दीजिए। हाँ?
Good morning, sir. I'm audible.
Yes, ma'am.
So, am I audible, ma'am?
Yes, sir. Good morning.
Good morning, and
On this auspicious occasion, it is proud privilege to invite our chief guest, Honorable Vice Chancellor, sir, Professor Vinay Kumar Pathak, to incite us with his inspirational thoughts. Sir, please.
thanks to all of you, and welcome to this workshop of data science and uh, uh, in the maths department. I think this is the need of our. We have to go through this kind of things where mathematics people are taking interest in the data sciences, and data science is a new course. All of us should also go and work in the data science area. I think our department has done a good work by holding a workshop. I had got some time to understand also the technical lectures. So I think a good number of technical lectures are going to happen in this workshop, which will benefit all the audience who have got in these workshops, who has got an participation. I think the applications are also very important, and mathematics has also taken the lead in this kind of work and in this area. I wish a great success to this workshop and wish you all very good luck. Please tell me what is the conclusion. Just tell me when it completes. Thank you very much.
Thank you so much, sir, for your guidance and inspiration. So now I would like to request Dr. D.K. Singh, Coordinator, Department of Mathematics, to extend and chair the technical session.
Yeah, madam. Good morning, ma'am. This is our second speaker, Dr. Rajita B. Dr. Rajita B is Assistant Professor in the Department of Computer Science and Engineering, Motilal Nehru, National Institute of Technology, Allahabad, Prayagraj. And she's completed her PhD from the MIT Allahabad, and she's research area is image processing, medical image processing, multimedia processing, machine learning in computer vision, deep learning in computer visions. Madam have published several papers in reputed national and international journals, and also the book chapters. And she have also received the award and honors from the different reputed bodies. Like this is here awarded as a graduate student exchange program fellowship by the Canadian Bureau for International Education, CBI, on behalf of Foreign Affairs International Trade Canada, University of Scotland, for a project work and worked as a foreign university during December 2008 to June 2009. So I request to Dr. Rajita B. ma'am overwhelm the participant with their knowledge. Please, ma'am.
Yeah, thank you so much for the nice introduction about me. Am I audible to all? first?
Yeah, you are audible, ma'am.
Okay, thank you. So, hope my screen is visible.
Yeah, sure.
Yes, ma'am.
Is the PPT visible now?
Yeah, yeah.
Yeah, fine. Thank you for the team from Chhatrapati Shivaji Maharaj University for inviting me for this lecture. And I could see that most of the people are from mathematics. So I would like to give a brief introduction on computer vision first, because I don't think how many people of you are well aware of computer vision applications and what are the scope if any AI or ML or DL in computer vision. I'm not sure how many people know already. So I would like to give a brief introduction about,
I know, ma'am.
you know, fine, then it is good. So you can raise some questions at the end after my lecture finishes. So,
Okay.
yeah. So let's start with some basics of computer vision. Then we'll talk about AI and how many ways we can do the AI. There are the various ways we can perform. And then I'll discuss a small topic on deep learning also, how it is adaptive to the computer vision applications. And then I'll conclude. So these will be my topics today for this session. And as already instructed, I'm Dr. Rajita B. Completed my PhD from MNNIT Allahabad, and I'm working as an assistant professor currently in the same university. Fine. And actually, I belong to Telangana, but I'm working over here. That is my background of my background of my studies and all. So I have completed all my BTech and everything from South India itself. Fine. So let's start with our topic, which we are gathered today. That is the role of AI in computer vision. So these are the basic topics which I would be interested in discussing today. So let me, okay. So we'll be talking about what is image, what is a vision, and then we'll talk about applications of vision. Then we'll talk about some brief introduction about AI and what is the need of AI in our vision. Then I'll talk about two different techniques which are part of AI, which we call as ML and DL. There is a further classification. I'll discuss that as well. So we'll be talking some methods in ML and some methods in DL as well, which could be helping us in resolving the challenges of computer vision. Right? Okay. Now, what is an image in general? So, as we all know, the images are something like we store or we create or we generate to save our memories. Right? So, that is a basic funda of having an image. So, basically, the images are, as we all know, there are two types. One is the physical photograph of an image, or the second one comes into the picture, which is digitized, right? Digitized image. Now, physical photograph in the sense that the photo frames, what you place on your wall, right? The photo albums, the photocopy, hard copies, what you take, all these comes under physical photographs, and we cannot process anything from those except with your digital visual eye. That means by only by looking at those photographs visually or manually, we can analyze something from those photographs. But what if we go for digitizing them? Right? That is the beauty of digitizing an image. So basically, any image, whatever we capture, we try to capture some information from it. Let's say I have an information of my family members photographs, then I can identify who all family members are present in it and what is the position and various information about what is the age and also age of the people when the photograph was taken. If this is in terms of my physical photograph, which I analyze by myself by looking at the photograph. Now, what if I design a machine which can do all these things to me digitizely, right? So that means I just scan this photograph and put it on my machine, and machine can identify whether its photograph is belonging to a general human or is it belonging to a trees, or is it belonging to an aeroplane, or is it belonging to something else? What exactly that image is for, and what information can we extract from that image? If something, some machine or some software intelligently, if it can analyze that information for us and give an analysis, that would be much better, which is needed in today's research, right? So for example, I have lots of applications to discuss this. So for example, simply I have taken the signature of a person, okay, and I want to decide whether the signature is a valid signature or not. So this application cannot be decided by every human, because in general all the civilians are not authorized to find out whether the signature is forged or not forged. That means only the experts who have done their research, or they have done some certified courses to identify whether the signature is forged or not forged. Only those people can physically can recognize or classify that signature. Now, but going to that person and identifying it, and there will be, if I talk about an organization which does all these things, like a crime, a CBI, suppose, let's say, consider a CBI, so where you get thousands of such cases. For every case, if you rely on a person or a human, then it will be a tedious task, and availability of that person will also be a tedious, challenging issue. So where we cannot find out the time to get it verified within the stipulated time. So we need an automated system. This creates a generation of automated system. Now, when I talk about automated system, now system is nothing but an app which is installed in your desktop or in your mobile device, right? So that should scan the digitized signature, and then there should be some algorithms running behind, or some ML techniques running behind, or some DL techniques running behind. That means technically some algorithm is running behind that software to identify whether the signature is forged or not forged, right? So we need to design such algorithm. Now that algorithm can be of any type. It can be a manual algorithm, or it can be an ML algorithm. It can be a DL algorithm as well. Till the research today, what is going on in this field. But basically, we need to know first the 3 individual steps. How to read an image into machine, what all formats we can store. Now, once the image is stored in my machine, how do I retrieve it? And how all formats I have the feasibility to retrieve it. And then I go for the algorithms. And before going into the algorithms, every image needs to be clear enough for processing. Right? Every image must be clear enough. That means if you see at this particular example or the slide which I'm presenting right now, it shows that a digital image is a representation of 2-dimensional image as a finite set of digital values called picture elements or pixels. That means, suppose if this is a particular real-time object which is actually physically present, on that object I want to take a camera and picturize it. I want to digitize the image, that particular object. Now I just click a press button on my camera or my mobile phone. Now this realistic object will be stored into my machine in form of a matrix. So that means you can see here each one, rows and columns. Let's say this matrix is of size m cross n. Right? Now, on this m cross n matrix, this object is going to be stored in terms of cells. Now, each cell is said to be a pixel, is termed as an pixel. Now, if you see this one, the second image, so this is my digitized representation of original object in my machine. right? So which is of size, let's say m cross n, you can take here 512 cross 512 or 200 cross 200 or 500 cross 600, anything randomly, which actually, if I talk about further, this size actually depends on the resolution of your camera, resolution capacity of camera. Now, depending on the camera resolution, the size of your image gets created. Now, based on that, each cell is created depending on the light source which is given onto the object, and depending on the illumination which is available, illumination in the sense that whether you have enough light or not for while capturing the photograph, right? So if you have taken a photograph in the dark room, obviously the object which is captured will be too dark. The object may not be classifiable. But if you take an image in the sunlight, that means outside your outsourced object, like in the garden or some park or something, then the photographs are clear, rather only in the case that during not sunny. If it is over sunny also there will be a problem. If it is less sunny also there will be a problem. So there should be a proper illumination light source to capture your photograph, right? So now once the photograph is captured, that will be stored in the form of a matrix. Now that matrix size depends on the resolution of your camera. Now every cell is said to be a pixel. Now that pixel stores the value depending on the type of image category. Now image category in the sense that is it a black and white image? Is it a grayscale image? Is it a colored image? So you have lots of variants of images, right? Now black and white in the sense that I have only two types of pixels, which is black and zero. So generally for black and zero, we generally denote it as 0 and 1. So either way we can take. It is not compulsory that always 0 to be background or 1 to be the foreground. It depends to us, but in generally in most of the machines, zero represents the black color and 1 represents the white color. Okay, so this is the standard notation of when you store an image in the form of black and white. So suppose if I have a digitized signature, something like this, I have a signature something like this. Now in that case, if I have taken the photograph, it will be captured like this. Now this entire region, which we call as a background, when I store in the machine, it will be holding a value 0 because it is background. And this one, only the signature part, the line part, I can denote it as 1 in my machine, right? So when I store this particular signature in the digitized machine, I'll be getting a matrix of size, let's say 50 cross 50. I'm just taking it as an assumption. Now it will be divided into some cells. Right? Now each cell will hold either 0 or 1. And if you see here in the first cell, it is actually white. So I can take this as, so while storing it, you can represent in both the way. But in general, if it will be good if you show background with a black and foreground with a white, because we are more focused towards the white, not the black. So for that clarity, I'm taking here the background to be 0. So I'll be having a 0 value here, always 0, 0, 0, 0 and all. So wherever the cells which are belonging to the signature part, let's say these are the blocks which are belonging to the signature part, the line wherein I'll have the cell value to be as 1, like this. Remaining all values will be 0. So when I look at this matrix, it will be showing the same matrix, which is in real time, which is a signature. It will be stored in the digital form in the pixels of black and white, where the black pixels represents the background and white pixels represents the foreground. That means the signature part. Now I can crop to only the signature region and then further process it, whether that signature belongs to me or somebody else. right? So like this, I'll store all the data in the form of binary, and I further process through some algorithms. I try to classify whether the signature is a black or white. Sorry, whether the signature belongs to person A, person B, or person C, right? So I can have many algorithms there. There are varied number of algorithms like manual, as I said, or AI based. You can do both the things, right? So I'll discuss them. What are the feasibilities of manual approaches and what are the feasibilities of AI based approaches? Fine. Now, before going to, okay, let's talk about the second one, which is grayscale. Right. Now, grayscale image in the sense that it is actually a black and white, but we have a shades of grays. Like instead of having simple black and white, I have a shades of grays, like the one which is shown in this figure. This one, which is called actually the grayscale image, wherein you can see that there are some white, completely white, less whiter, complete black, less blacker, and so on. So this is actually because to show the variations in the object region. Suppose if I take an apple, let's take an apple example. If I have taken the photograph and of an apple, obviously, if you see visually, apple, the outer region of the apple, some at the corners it will be pure red color, and in the some regions it will be light red color. It will be in light red, and in some regions it is too dark red. And some regions it could be a whitish region also. If you simply observe the color of an apple, varied color of an apple. Now, when I capture the photograph of the same thing should be reflecting on my digital image as well. It cannot be red pixel everywhere in the apple region, right? So, depending on its originality, the similarity should be existing in my digitized image as well. That can be reflected through these shades of whites and blacks, right? So if you have taken the grayscale image of an apple, then the darker regions of red color will be shown in black. The lesser red regions will be shown in somewhere in the gray, and then whiter regions which are actually in the apple boundary or at the center of an apple, those things will be shown with a white color, right? So like this, there is some logic behind how the pixels are chosen, how the range of the pixels are being chosen, right? Because all you are, most of the from mathematics, you know how to generate this range of pixels. Now, when I talk about grayscale, then obviously if my image is of 2-bit image, then I'll have only 2 very number of bits. But in general, the camera, whichever we try to focus on, it's minimally, with minimum to minimum, it starts with 8-bit. 8-bit camera, capacity camera, right? Even in today's environment, in today's cameras upgraded cameras, you can find 32-bit cameras as well, right? So if I talk about the least one, 8-bit camera pixel, then it will have the range of blacks and whites in the form, in terms of the values will be in the range of 2 power 8. That means the value will range between 0 to 255. So white pixel denotes the black value, 255 denotes the white value, pure white, 0 denotes the pure black, 255 denotes the pure white, and remaining values denotes the grays or shades of black and white respectively. Right? So in that case, if I take that scenario and look into the pixel organization in my machine for this digitized image, then this value will be 0, this value will be 0, this value will be 255, all the background circles will be 255, and this value, because it's not pure black, not pure white, so it will be something around 50, not 50, let's say it is 150, because 255 is the purest white, but it is not purest white, it is somewhere in between, so it will be in the range between 0 to 255, right? So like this, there will be a matrix in my machine which holds these values, either 0 or 1 or 2 or 3 or 4 or 250 or 1 to 55, respectively, according to the original object colorization. right? So like this image gets stored on my machine in grayscale. Similarly, if I talk about color image, obviously we need to have RGB because every color gets generated with 3 components combination: red, green and blue, right? So if I talk about that, suppose if I talk about grayscale image for the same object which is in the screen, I'll have only one matrix of size m cross n cross 1 because only one matrix is sufficient to store this object in the form of a black and white. But if I store the same image in the form of a grayscale, then also it is sufficient to store the object in the same one dimensional matrix, which is m cross 1. Right? Because I'm not having any other, I don't need any other pixel. I just store the grayscale values within the range of 0 to 255. But if I talk about a color image, every pixel, each pixel is generated with the component of R, G and B. So there are requirements of 3 values to generate one value, right? There is a requirement of 3 values to generate one value. So here the matrices will be actually 3. So if I see this, this is my R matrix, that means the red component in that image. This is G matrix, that means the G component in that image, and the blue matrix, which denotes the how much blue color has been combined to generate that color, right? So that means for color images, the size component for each image will be in the size m cross n cross 3 because you need 3 matrices to generate that image. Right now, by looking at these 3 itself, it is very clear that for black and white, I have to process only my processing time to analyze anything or to processing time required to extract some information from black and white image is only m cross n because I have to just process m cross n pixels. Even in grayscale is the same. I just have to process m cross n pixels. But if I'm trying to process the color image, the complexity increases here that I have to process m cross n cross 3 number of pixels, right? So in general, most of the images what we capture through your camera or through some CCTV footages, you can say, surveillance cameras, you can say, or even with the photographs taken through your desktop, you can say, all these images are in the color format only, right? They all are in color format. That means, in general, 90% image what we capture in real time are in color component. Right now, when I talk about generating an algorithm to extract some information from those color images, obviously my complexity of those algorithms will be very high because I have to work on m cross n cross 3 number of components every time, right? So how I can reduce this complexity? Right. So what people have suggested, or you can say some researchers who have done research in imaging field or computer vision field, what they do is either they work on converting the color image into grayscale because my dimension gets reduced. M cross n cross 3, the dimension, I have reduced it to m cross n cross 1. Right. So suppose if I have to simply classify, let's say one simple example, I have a scanner, camera scanner, which is moving in the fruit market, and it has to simply classify the fruits. That means by scanning, it has to tell me whether the fruit belongs to apple, whether the fruit is banana, or whether the fruit is an orange or something else. If this is my automated system which I have to generate, in that case, color plays a vital role, right? But shape also plays a vital role, right? So if I neglect the color component, if I just look at the shape component, then also my task will be achieved to 90%. I cannot say 100% because some of the fruits will be of similar shape. but the objects are different, right? So those cases I'm neglecting. I'm simply taking the assumption of the large classifiable fruits. Now, in that case, instead of working on color component, I can convert that colored digitized image to grayscale and then run my algorithm on that by recognizing the shape of that particular fruit to classify it, right? So for this, I can write an manual algorithm to extract the shape of my fruit, right? Or else I can go for AI-based approaches, both the things. Right? So, like this, in real time, whatever application you work on, the images what you capture in real time, most of them are in color, but in 90% real time applications, we don't need color component. So we convert them into grayscale and then we try to process the application. Right? So, but if there are some 10% critical applications where you need color component. Right. For example, in the same application of fruit classification, if I add one more component, classify the fruit, as well as find out whether the fruit is good, healthy, or damaged. Right? Whether the fruit is healthy or damaged. That means, is there any fungus on the fruit? Is the fruit got damaged due to some decaying? Right. Now, this information obviously shape cannot identify. You need to go for color component at any cost. Right. So, in such applications, color component plays a vital role because it's so we have to work on color images only. For example, if I take another example, another application, wherein I have to classify a criminal. Okay, let me say I have to identify a murderer in critical conditions. There is a mishap. There is a person called X. He has gunshotted one person. He has murdered one person at location A. Let's say in Delhi. It's some location. Okay. Now, immediately he won't stand there after he gunshots. Right. Now, he will be running out from there either through two-wheeler or four-wheeler, logically. Now, if the report has been made to the police people immediately at the time of crime or after the crime also, what is the task of the people, the police investigating team? They first try to find out what is the location, what is the possibility of that person moving from that location. So he will look into all the cameras which are located in that particular place to the connecting locations which are there in south, east, west, and north. He will be looking into all the cameras. Right? Now he will analyze the cameras and he will be looking at the vehicles because human face or something will be, he might wear a mask or something. So through face, we cannot identify. But if we know the type of vehicle on which the person has come, then we can track that person through the type of vehicle. Now, when I talk about this application, for sure, 100%, I need the color of the vehicle as well as the number plate of that vehicle. First, criminal, the police investigation team will look into the crime location camera. They will identify what type of vehicle has been used, what is the number plate of that first vehicle, and they try to track that vehicle in all the directions which are possible from that location to move on. Right? Now, that tracking actually is done through the three components again. First is the shape of the vehicle, color of the vehicle. So both are playing a vital role. Similarly, the number plate. Right? So these three things plays a vital role in recognizing it. अगर इस सारे काम को अगर एक normal person करेगा तो actually generally most of the applications in criminal investigation also there are people dedicated to that. If there is a mishap, something like that, there are some people dedicated for this task in police services also who try to analyze or look at the cameras and try to identify the person manually. But in today's research, there are some systems, people are trying to develop certain systems, automated systems by looking at the criminal. Once you got the initial frame of the object or the vehicle which is being used in the crime, that can be tracked automatically in all the direction cameras which are possible, movable locations are present. So automatically it can be identified through either through manual algorithms or with the DI algorithms. So AI is playing a vital role in such applications. Either it could be a fruit classification or could be a criminal identification. So AI is playing a vital role. Okay, so now one more thing I'll tell you the difference between the manual approaches, when we go for manual and when we go for AI based approaches. Now in manual approaches, as I told you, suppose if my every image which I have to process, if it is of size m cross n cross 3, let's assume I have 1,000 such images which I have to process. Now each image is of size m cross n cross 3. Now if I'm taking any manually if I have written any algorithm, then this algorithm must process on m cross n cross 3 cross 1,000 images. Right, this much it has to process, and processing all those pixels may not be required in real time because it is very too much complex. Right, so that is why AI comes into the picture here again, which actually focuses on, rather than working on m cross n cross 3 cross 1,000 number of pixels, I can focus only on the corners or the most important regions of those each image. That means instead of working on these many number of pixels, I can reduce my number of pixels to, let's say, 500 pixels only I have to process, not everything. Right, now how these 500 pixels have been decided, that these 500 are important in each image for classification or for object detection or something else. That is done through the AI. Okay, artificial intelligence helps us in deciding or identifying or extracting those important features. Okay, so that is the beauty of AI in imaging, or you can say in vision. So AI, image and vision are nothing but, image is actually a digitized image, as I said you. So this is a grayscale image and this is a color image. Right, so this is a representation. Now when I take a sequence of such frames, now if I talk about this one, in general you can take it consider this as an image, but if I consider this as a frame, and if I talk about the sequence, there are many frames, frame 1, frame 2, frame 3, so on up to frame 100 or 1,000, let's say. When I take the collection of frames and run consecutively, then it becomes a video. That means, actually I'm talking in terms of image to video. Image to, initially images were generated, now group of images are clubbed together to make a video, actually in real time. Right, but people understand in reverse, that is, a video is given and from video there are frames generated. Frames are generated. Right, that is also acceptable, that is also the correct, this is also the correct. To create a video you need thousands of frames, millions of frames, but if you want to process a already generated video, then from the video you need to extract the frames first. Right, so like in CCTV footage example what I was talking about in the just previous slide, wherein you will not get frame by frame. Right, so you will get a video running from hour 12 hours to 1 hour. Right, let's say from 4 p.m. to 5 p.m. extract the video and try to identify whether the criminal is present in that location or not. So you will get 1 hour video to process. Right, now from that video you are going to extract the frames. Now on those frames you are going to process your algorithm or your AI technique to recognize whether the criminal is present or not in that video, or if he is present, to which location is he moving. Right, so For extracting the data from a video, you need to convert into frames. There is nothing to be getting confused here. To generate a video, you need collection of frames. To analyze a video, you need again a frames. So you are converting video to frames or frames to video. Both are applicable depending on what type of data you got. Accordingly, you have to use them, right? So basic logic is that computer vision applications means the video processing based applications. Digitized image processing means you are working on each individual frame. Okay. Vision matlab ki you are actually talking about videos. You can take that classification. So it's image processing is a part of computer vision. So if you are not clear with image processing, then computer vision will not be adaptive to us. So we have to be clear with the image processing first. When the concepts which are adaptive to process an image, then we can go for real-time applications of computer vision. So these are though interrelated. The basic rule is that first we have to have a clear idea on digital image processing. Then we have to go for computer vision applications. Right. So now if I talk about digitized image processing, then there are many things which we can do in general image processing. Now, first thing is that we acquire the image, capture it through a small click on your camera. So on that photograph, you can apply enhancement. That means the image which is captured, as I told you initially, while capturing your photograph, there could be enough light source or there could not be enough light source. Right? That means the image might be in three cases, either too dark, either too bright, or moderate for processing. Right? But in general, whatever algorithm you apply, either you apply manual algorithm or an AI algorithm, the image must be clear enough to us. First step, basic step. So that means if you have an image which is too dull, enhance it. If you have some noise added to image, then remove it. Right? So it is enhancement talks about clearing your image. That means correcting the factor of illumination. You can also call it as brightness adjustment. Most people understand through the term called brightness adjustment of an image, where you can, that brightness adjustment is nothing but an image enhancement. Similarly, there is another one. The next step is that there could be a possible that जो भी मैंने image लिया, read किया, that image might be having some noise, right? Some noise, some disturbance on the image. So there are varied number of algorithms again in digital image processing which can remove those noises from the image. For example, like this. So this image X is actually corrupted with some noise. So we apply some DIP techniques, we get a clear image, which is image restoration. Similarly, you could do some morphological processing, you could do segmentation, you could do object recognition, you can do representation, you can compress the image for transferring over web, and we can do color image processing also. So for example, if I see this is morphological processing, which means that I have an image, thumb scanner. I have simply taken the thumb scanner. Now, depending on the thumb, I have to classify whether it is belonging to person X, person Y, or person Z. For that, as we already know, thumb is treated as a biometric identifier, right? So we can have we are having lots of algorithms for that, but basically the scan image, whatever you have taken, the image should be clear enough with all the lines and corners and edges, which we call as ridges, right, in technical terms. So for that, we need some DIP techniques called as morphological processing algorithms. There are many algorithms in this again, so which we can use for clearing the thumb scanner. So it is not only for thumb, you can go for the number plate classification also, wherever there is a black and white combination based applications. So like your thumb recognizer is one. Signature verification is another application. Similarly, you have number plate classification, yeah, character classification. Suppose if you have a textbook को मैंने scan कर दिया data. I have scanned the textbook because it is very old textbook, like 1900 or 1910 या 1820 का textbook अगर है, I don't have a digitized copy of that. But I want to identify the language what is being used in that. So in that case, you need to take the scan of that photograph and provide it to an automated system which can identify the language of that scanned data, textbook data. Right? Where again, when you scan it, it is fine, but there is no machine directly scanned image को directly process करता हो. Right? So इस scanned image को पहले हमें we have to identify the characters in it, and not exactly the characters, but you need to identify what is the how many number of such characters are present. Suppose simply if I talk about this one, I need to find the boundary of this, then R, then P, then F, H, then O, then L, then O, then G, then I, C, A, L. Like this, I have to find each individual character and send it to my machine so that it recognizes that that character is M, that character is R, that character is H. And then it can say that these characters used in that particular scanned textbook image is belonging to the English language. Right? Similarly, if you have any French language text, again you have to classify those characters and then send it to the machine, and it will show me that it will classify that, or it has to classify that the text belongs to French language. Right? So even if I forget about foreign languages, only in India there are many languages actually. Right? Even if you do a research on simply scanning the text and classifying the text into multiple languages of an India, that will be a good application in today's research field. But because there is no such application currently available in the market or in the research current on today's date. Right? So there is a wide research scope in doing such applications as well, where you can take the language classification. If you look at most of the Google Scholar, में आप लोग तो ढूंढते ही होंगे. If you simply type a language classification based research articles, then you will see the research articles. I won't say that you will not get such research articles, but those research articles are basically meant to classify Hindi, Sanskrit, English, and then some languages like Telugu or Tamil or something. Only there are few classifier researchers, applications or applications or apps or research algorithms are present. Only for small set of language texts. So if somebody can take up this challenge and work on all of them, that will be one of the good research challenging area in today's research field. Because see, why AI is required? Simple example, I belong to South India. Let's say I belong to South India. I cannot read Hindi. I cannot understand Hindi. Similarly, I cannot understand any other North Indian based languages like Punjabi or something else, Rajasthani, or they speak generally Hindi, but I don't understand. There is a variedness of Hindi also. So I don't understand, and I don't know how to read Hindi also. Let's assume. So in that case, if there is some software which can just scan the text or the banner information and convert that to me in the form of English, if I could understand, or if it can convert that text into my Telugu language where I could understand it betterly. Right? There are some research people who are working on this application through AI, but the limitation is the scope of those research is very limited to identify the name plates. स्पेशली जितने भी लोगों ने रिसर्च किया है इस पे नेम प्लेट्स पे ही उन्होंने फोकस किया, क्योंकि उन्होंने पूरे टेक्स्ट को एज अ पैराग्राफ को एज अ इनपुट मान के नहीं किया है आज के डेट तक भी रिसर्च में. राइट? तो उन लोगों ने बस ये किया है कि अगर कोई बंदा एक पर्सन इज मूविंग फ्रॉम दिल्ली टू तमिलनाडु और फ्रॉम केरला or from Kerala to Delhi or Punjab or Bihar or something, the name plates, because he needs to know the route map, right? So जितने भी name boards होंगे वो हिंदी में लिखे होंगे, right? So the research has been limited to only that नेम बेड पे क्या लिखा है उसको कन्वर्ट करके हिंदी में कन्वर्ट करे या फिर सॉरी इंग्लिश में कन्वर्ट करे या रीजनल लैंग्वेज जिसका उसका केरला है या जो भी है उसमें कन्वर्ट करने, इसके लिए एप्लीकेशन है अवेलेबल, बट दैट इज आल्सो चैलेंजिंग, दैट इज आल्सो नॉट 100% वर्किंग, राइट? सो there is a wide scope of AI in vision based application. That is why I'm telling this particular application especially, right? So this is a language barrier which is actually for either South Indians to North or North Indians to South, or it can be something like if I move to German, if I move to China, if I move to French or based province, right? If I move to US, UK, they speak English, but their English is far different from the English what we speak, right? So there is a huge language barrier when I talk about communicating among the multiple states or multiple countries. So there could be a good AI-based algorithms which can be used in this particular application, wherein you can design vision-based applications, especially because in all these applications you need to scan the data first, right? So whenever something is scanned, it is digitized, and that when it is digitized, it is image or video. Again, you have to go with the vision-based, AI-based applications to identify or convert that language and so on. So this is one of the brightest region of area of research, you can say, wherein language barrier problems can be resolved if people do focus on this particular type of applications. Okay, and the remaining are like there are such applications like image segmentation, then representation, object detection. Now, object detection is one more application wherein AI is widely applied, as I could say. Now, this is something like if I'm given a CCTV footage, I can identify humans, objects. I can detect two-wheeler objects. I can detect four-wheeler objects. I can detect heavy-wheeler objects. And I can detect the climatical conditions. I can detect the buildings. I can detect the trees. I can detect the rivers. I can detect whether there is a fire in some location or something, right? So like this, there are varied number of object detection based applications in real time where video is taken as an input, and from that video you are going to apply some manual techniques or AI based techniques to recognize the objects. Now, what you target on once you have object has been targeted, identified, that is a different thing, I could say. But basic object detection के लिए भी बहुत सारे researchers ने काम किया हुआ है. If you look into simply Google search में डालिए आप लोग, अगर कोई भी interested हो इस field में, Google में डालिए the object detection classifier data set. Object detection classifier data set. सिंपली डाल दोगे तो आप लोगों का केगिल का बहुत सारा डेटा मिलेगा जिसमें कार हैं, ट्री हैं, व्हीकल्स हैं या हेवी लोड व्हीकल्स हैं, ह्यूमन हैं, लाइक फोन है, मोबाइल है, लैपटॉप है, डेस्कटॉप है, इस तरह की बहुत सारा डेटा सेट अवेलेबल है ऑलरेडी ऑन गूगल, राइट? अगर कोई भी इंटरेस्टेड हो इस फील्ड में, दे कैन ट्राई टू गेट द डेटा, एंड देयर आर मेनी पीपल हु हैव ऑलरेडी डेवलप्ड एप्लीकेशंस. मतलब कि बहुत सारे लोगों ने जो रिसर्च 20 आई कुड से दैट 2015 के पहले जितने भी लोगों ने पब्लिश किया काम ऑब्जेक्ट क्लासिफिकेशन पे, मेजॉरिटी ऑफ पीपल ने 80% पीपल ने मैनुअल अप्रोचेस ही यूज किए हैं, मतलब उन्होंने खुद से अपने एल्गोरिथम डिजाइन किया. लेकिन 2015 के बाद जितने भी पब्लिकेशंस आप देखोगे तो मोस्ट ऑफ द पीपल 98% people ने AI based techniques use की हैं because it is faster, it is more accurate than your manual approaches. Manual approaches में challenges हो जाती हैं कि मैंने कुछ सोच के अपने तरीके से algorithm बनाई है, वो कुछ assumptions पे ही काम करेगा, कुछ assumptions पे हो सकता है नहीं काम करे, right? But when you talk about AI based applications using ML or DL, ML with machine learning techniques or deep learning techniques, then obviously it tries to fetch the complete information of your image or video, right? Which will be more adaptive for current generation applications. Right. So like that, AI is playing a vital role in object classification, image segmentation, image representation, and image classification, and crime identification, anomaly classification. Anomaly classification मतलब है कि एक CCTV footage है, मान लो एक सेक्टर पे रखा है मैंने, ट्रैफिक सिग्नल्स पे ही जनरली सीसीटीवी की फुटेज क्राइम्स तो वहीं पे होती हैं, जनरल अपने घर पे भी तो क्राइम्स होती हैं, तो मोस्ट ऑफ द पीपल दे ट्राई टू प्लेस अ डिजिटाइज कैमरास set up in their homes, at their business locations, as well as in the malls, in the traffic signals. इन सभी पे हो सकता है कभी ना कभी कोई बॉम्ब ब्लास्ट हुआ हो, या कोई फायर एक्सीडेंट हो गया हो, या कोई अर्थक्वेक हुआ हो, या फिर कोई मर्डर हुआ है, राइट? सो दीज आर ऑल कॉल्ड एज अनोमलीज. कोई रॉबरी हुआ है पर्टिकुलर लोकेशन, एक मॉल है वहां पे एक रॉबरी हो गया है, बट एवरीथिंग इज बीन कैप्चर्ड थ्रू द कैमरास, राइट? सो नाउ ऑल दीज anomaly detection applications, or you can say anomaly classification applications are also present, wherein AI plays a vital role to retrieve or to classify that challenging task in lesser time, in shorter time, rather than your manual approaches, right? So like that, AI is playing a vital role in most क्या मैं तो कहूंगी कि 99% ऑफ विजन बेस्ड एप्लीकेशंस में AI की जरूरत है ही आज के डेट में. अब AI में आप लोग ML यूज करते हो या DL यूज करते हो, दैट इज अप टू अस, राइट? नाउ हाउ डू that AI or DI actually correlated, as I told you, computer vision is actually a collection of frames. Now these frames में मुझे exactly analyze करना है कि whether I have to recognize a person or whether I have to recognize a human, vehicle, whether I have to recognize a two-wheeler or something else. So उसको कहेंगे हम analyze. तो किसको actually हम target कर रहे हैं? So to analyze that, you need to work on the basic image, right? So image processing is required for analyzing the objects or information in that frame. Now, once you analyze that some information from that frame, you're going to apply it for the computer vision based applications, whether it is recognition, whether it is a classification, whether it is a tracking of a person, whether it is a tracking of a vehicle, or whatever it could be. Or it could be some fire identification or fire detection or murder classification or something. Whatever things we do, everything of vision will be in this particular set: computer vision, analyzing, and processing. Okay, so this is a basic of computer vision, wherein we require image processing. Okay, then comes to vision. Actually, computer vision is a study of analyzing the pictures in the form of videos and which are stored in your machine. Obviously, every camera video is stored in your machine, and it is actually an interpretation how we are going to analyze, right? So instead of having a human eye visualization for every location, we have created cameras to have a visualization of all those locations. So cameras are nothing but the human eye resemblances devices, right, which are used in most of the CCTV footages or surveillance applications. So let's talk about, okay, directly we'll go for These are all the basics which are present in the slides. Once I give the slides, if anybody interested, go through them. Okay, current research applications, as I discussed already some of them, I'll further discuss a few more. So this one already I have discussed, number plate classification, as I told you. So if I talk about a number plate, initially first thing of our target is to segment the region of number plate. I'll segment the region of number plate first of all. Then on that apply segmentation or enhancement, you can say here enhancement, clear enough. तो मैंने कहा था कि एक बार image जब भी capture होती है, it is not mandatory that that image is clear enough for processing, but for processing that image must be clear enough, right? So we have made some brightness adjustment in that image, and through some image processing techniques only, there are very number of image processing techniques. So उसको apply करके हमने एक very well clear image बनाई है यहाँ पे. Now this image is further sent for character recognition, right? तो मैंने कहा था कि character recognition के लिए पूरे set text को नहीं भेज सकते हम, तो we have to divide each individual character, whatever language it could be, but we have to decide what is the region of each character. तो यहाँ पे हमने हर कैरेक्टर को सेपरेट किया 28 LYCH 428. अब ईच कैरेक्टर ब्लॉक को, हर एक ब्लॉक को हम भेजेंगे कैरेक्टर रिकॉग्नाइजर सॉफ्टवेयर पे, राइट? कैरेक्टर रिकॉग्नाइजर सॉफ्टवेयर पे ईच इंडिविजुअल ब्लॉक को हम उस पे भेजेंगे. तो दिस इज ऑलरेडी अ जनरेटेड सॉफ्टवेयर which character recognizes whether it is a 4 or whether it is a 3 or whether it is A, whether it is B or something else, right? So these all steps are mandatory required in this number plate classification, right? So this is one real time application of character recognition. तो इसी को और extend करके जैसे मैंने application बोला था उसको भी हम कर सकते हैं कि language recognition and translation to the respective the third language, the second required language, right? To remove the barrier of language either in within state, within country or outside the country. So there also you can extend this application further to recognize that language or classify that language. Another one application in real time is face detection, which you already know. आप लोग फेसबुक पे अपने फर्स्ट प्लेट अपलोड करते हो, ऑटोमेटिकली एक टैग आ जाता है हर पेज पे, मतलब कि एक एल्गोरिथम इनबिल्ट रन हो रहा है जो डिटेक्ट करता है कि 2 आई, नोज, माउथ अगर है तो उस पे एक रेक्टेंगुलर बॉक्स जनरेट कर देगा, राइट? सो नाउ दैट रेक्टेंगुलर बॉक्स पे हम टैग कर सकते हैं वेदर इज अ पर्सन ए, पर्सन बी और पर्सन सी, राइट? सो लाइक दैट देयर आर वेरी नंबर ऑफ ऑलरेडी applications available to recognize the face region. अब इस पे फिर से बहुत सारी एप्लीकेशन है रियल टाइम में, लोगों ने किया भी है. अगर फेस डिटेक्ट कर दिया है, well and good, good enough. Now there are varied applications. Once your face is detected, classify the whether the person belongs to US, UK or India. That is one set of research, people are working on it. And there is another thing, what is the emotion of the person, whether the person is sad, whether the person is happy, whether the person is crying or is he moody, what is the expression of the person while capturing that photograph. That also can be captured, or there are some algorithms already the people have done on that. Varied research has been done by many researchers in that field as well. So the people have proposed some algorithms in that field as well. Okay, so once a face is detected, you have n set of applications again, right? Age classification, gender classification, right? Depending on the skin color, also you can classify the person, right? So like that, there are varied sets of applications which are present in face detection based applications, right? That is one more application that, as I told you, smile detection. यहाँ पे तुम आप लोग देख सकते हो कि there are many people Same person in different emotions. So wherever the smile is there in the face of the person, it is said smile captured. But remaining frames में कुछ भी नहीं दिखाया है. राइट तो जिस फ्रेम में वो स्माइल कर रहा है उन्हीं को हमने हाईलाइट किया, बाकी चीजों को नहीं किया. सिमिलरली वॉट एवर इमोशन यू वांट टू कैप्चर, दैट थिंग कैन बी डन थ्रू the videos based frames. On frames you run some algorithms and extract the emotion of the person. नेक्स्ट इज योर सुपरमार्केट में. आप लोग सब लोग जाते हो सुपरमार्केट में, ऑटोमेटिकली एक बारकोड स्कैनर होता है जिसपे स्कैन करने पे उसका अमाउंट पूरा ऑटोमेटिकली आ जाती है. राइट नाउ दैट इज इन इंडिया. इन फॉरेन देयर आर सम सुपरमार्केट्स where there is no person who can bill your contents, your groceries. For that also there is an automated machine available, for which you just take the pick up the product or grocery item, place at the at the camera. It will identify how many objects are present, and depending on that object barcode, it will generate the bill automatically, and you will pay either with the credit card or through you can pay with your respective credit card or UPI or whatever, and you can get the data. You can get your products done, built done, right? So this type of automated applications are also already present in most of the supermarkets in today's business. One more application is vision based biometric, right? So बायोमेट्रिक में बहुत सारी चीजें आती हैं, जैसे थंब आ गया, आइरिस डिटेक्शन. दिस इज वन ऑफ द एप्लीकेशंस ऑफ आइरिस, बिकॉज जनरली ये माना जाता है कि या इट इज नोन दैट आइरिस जनरली डजंट चेंज इन अ पर्सन, right? The shape of your eye and the iris ball which you have, unless if you have not kept any lens, right? Now that doesn't generally change unless if there is a chemical reactions in your body. Other than that cases, it won't be changing for a particular person A. So that can be used as a biometric recognizer for an individual identification. So there are many such applications which can recognize the iris, based on which the person can be identified. Okay, so there are some set of applications. And one more application is, instead of going for, as you know, now people have become actually lazy. Most of the people have become lazy. They don't want to type anything. Automatically the system should open your laptop or your mobile. It should open by scanning your face or simply the thumb scanner. Day by day the people are becoming lazy. Generally, see, whenever there is an invention of AI, it means it is reducing the manpower requirement or intelligence of manpower. So that means actually we are making people lazy. But in most of the, I won't say this is bad, but this is good in most of the cases. Unlike your mobile opening ke liye bhi face recognition kyun chahiye when you have hands to type it. So it will be suitable for the people who cannot type, the people who are disabled. Right? So focus in that orientation. Don't make yourself lazy, but think innovatively depending on the disability of the person. Right? So there are some applications in that, which is AI is again playing a vital role. Similarly, location identification and so on. There is also wide range of applications. And cinematic field, if I say, like all the CGI based movies, cartoons, everything, there again the AI must work on. These are all the AI based motion pictures, right? Even in sports, in sports, in today's sports, if you see, within fraction of seconds you will get the running commentary and you will get the results, because you have lots of cameras placed in entire ground of the game which is being played, due to which there are huge sets of photos which are available immediately, and the zooming capability to identify the incident in any game is the zooming also has increased a lot, due to which it is playing a vital role in immediate so the AI is being applied widely. Similarly, smart cars, automated cars, it's one such application. Google cars, if you look at Google's car, it is a navigator machine. It tries to identify the navigation. Similarly, one more application is Kynet, which we call as interactive games, right? Similarly, vision in space, the satellite imaging processing. There also you have lots of AI involvement to identify them or localize them. Similarly, one more application where we can apply AI is industrial robots, robotic based applications, your arm based robot or your vehicle based robot, or something which is sensing whether there is a person or not in that room. If there is a waiting hall, let's say, which is the waiting hall, the power consumption अगर हम लोगों को convert करना पावर कंजप्शन को अगर रिड्यूस करना है, उस वेटिंग हॉल में कोई पर्सन बैठा है तभी लाइट्स ऑन हो, अदरवाइज द लाइट शुड बी ऑफ in that waiting hall, right? So there could be some sensors placed, or vision based sensor we can place it. It recognizes whether is there any human present in that room or not. If there is a human, on the lights, else off the light, right? So such small sensor based robots can also be designed depending on the application. Again, a simple example I told you. Similarly, there are wide number of robots, drones. If you can see in today's world, there are many drones which are moving from one place to the other and capturing wide sets of data, right? Robots have been applied in surveillance also, right? Criminal identification also, especially in borders also they are deploying the robots, right? So like that, there are very number of applications where robots are designed with faster intelligence using the AI based algorithms. Okay, so AI being applied in most of the vision based applications. So robots, these are varied robots which are already present in the market. Another field where we can apply AI is medical image processing, tumor identification, tumor classification, blood cells clotting, or else your operation also, C-section operation, your heart surgery, right? And bone surgery, all these types of applications needs vision, wherein these days the vision based x-ray machines, MRI machines, or CT scan machines, these are actually incorporating AI to identify the data in faster way and intelligently. For example, if I have a tumor in my brain, if any person has a tumor, now first thing is that it has to identify the tumor, then what is the stage of the tumor. Now, on that tumor, will it work through medicines or not? Do I have to give a radiotherapy, right? Or do I have to go for completely operation to remove that tumor, right? Now, these all information generally आज के डेट में रेडियोलॉजिस्ट के पास हम जाते हैं एमआरआई करवाने के लिए, तो रेडियोलॉजिस्ट सिंपली स्कैन्स your MRI sequence data and he projects them onto the report, mentioning that how much width or height or location of your tumor present in that person, right? In a hard copy bound report. Now, doctor actually analyzes this and accordingly he treats it, right? Now the challenging task comes here. What if the doctor is not so experienced? Are you getting it? What if the doctor is a just recent doctor? He has just passed his or completed his master's in doctorate, postdoc and something, and he has come into the field with only 1 or 2 years experience, right? In that case, he will be analyzing or he will be diagnosing the person only based on his expertise, not on the expertise of existing doctors' knowledge on that platform or for that disease. Right? Now, that is why we people face problem that I have shown my results to some hospital A and they have treated something, but it is not cured completely. So I'll be rushing to another hospital B, wherein I found that the doctor is expert in that field. Again, I go for medical reports and everything, and again I get treated. Even if it is not diagnosed, then I'll go for even more experienced doctors who are in foreign, some Germany or US or UK or something. Then I go for there and I then get treated it for that particular disease. Right? But in real time, in doing this entire task, it will take around 1 year or 2 years to complete it. During that period, the tumor or the cancer might become very dangerous and the person life will be a challenging one. Right? So what if we can develop some AI based techniques here and design one software through the help of all the expertised people in the overall world by taking their opinions and generate one automated machine which can give an approximate analysis on that particular disease, on that particular person's images based on the expertise available throughout the world doctors. Right? Now that will be, I won't say that will be giving 100% solution for this application, but the person who is less experienced, he can get the wide possibility of looking at the disease in depth. Right? In depth. Now, when he looks into this particular scenario in depth with existing knowledge of that information, it could be possible that he can think about diagnosing that patient in multiple orientations, and then he can talk to those expertise people separately and get some information from them, and then correctly diagnose that particular patient X. Now in this case, if I have such AI-based machines which are available for all the doctors, whether it is experts or non-experts, then diagnosing the patient becomes easier, and also the patient can recover fastly. Medical treatments can be made fastly. Right? Now, in this case, the people might ask you why the experienced people will share their data. Right? Now, I can resolve this also, or we can try to resolve this also. There could be a tie-ups between the expertised peoples through MOUs or something, and we can exchange the data among the expertised peoples through AI-based techniques again. Right? So the AI plays a vital role in designing all such applications which are very, very helpful to the current society. Right? So like this, we can adapt AI in most of the techniques, especially in medical field. I feel that AI should be applied and the diagnosing should be done faster so that the lifespan of the person can be saved or increased. Right? So this is one good research of field where you can apply computer vision based applications. So in general, every computer vision based application will be relying like this, AI based algorithms. So artificial intelligence is actually a generalized term. Now this is further divided into machine learning and deep learning. Now machine learning techniques are the things where we train the machines, but machine is being trained with some known information, but that known information is given by us manually. That means, for example, जैसे अभी मैंने एग्जांपल दिया था कि सारे एक्सपर्ट्स के साथ बात करो फिर डिसाइड करो, राइट? सो इन दैट केस आई कैन हैव एन क्वेश्चनर आंसर सेक्शन जो मेरे पास सभी डॉक्टरों को मैंने एक सर्वे भेजा क्वेश्चन आंसर सेक्शंस का, और उसके बेसिस पे मैंने एक एक्सेल शीट बनाई है जिसपे पूरा डेटा गैदर्ड है, जिन जिन डॉक्टर से मैंने बात किया, मान लो 1000 डॉक्टर से मैंने बात की और कुछ क्वेश्चन आंसर्स किए हैं ट्यूमर के रिगार्डिंग, तो उसके बेसिस पे मैंने उस ट्यूमर को 3 क्लासेस में क्लासिफाई किया, द स्टार्टिंग स्टेज, मिडिल स्टेज एंड सीवियर स्टेज, राइट। तो मैंने कुछ न्यूमेरिकल वैल्यूज ली हैं, एक CSV फाइल जनरेट किया है या एक्सेल फाइल जनरेट किया है विच इज कंप्राइजिंग द डेटा ऑफ वेरियस डॉक्टर्स टू क्लासिफाई द ट्यूमर। इस पे अगर मैंने क्रॉस एल्गोरिथम अप्लाई की है करने के लिए मैन्युअली, और मैन्युअली फीचर्स एक्सट्रैक्ट करके मैंने कोई एल्गोरिथम्स अप्लाई किए हैं फॉर क्लासिफिकेशन, दैट कम्स योर ML टेक्निक, राइट। DL टेक्निक में क्या होता है कि हियर आल्सो वी डीपली लर्न एवरीथिंग, but the thing is that the separation here is the feature extraction is also done automatically। जैसे कि मेरे पास बहुत सारी इमेजेस हैं ट्यूमर्स की, उन पे डायरेक्टली मैंने कुछ कन्वोल्यूशन न्यूरल नेटवर्क्स अप्लाई किया और उनसे फीचर्स एक्सट्रैक्ट किए। मैंने डॉक्टर से नहीं पूछा, मेरे पास मिलियंस ऑफ डेटा था ट्यूमर डेटा के लिए, उस पे मैंने कुछ विजन बेस्ड एप्लीकेशंस अप्लाई करके हर एक इमेज से मैंने फीचर्स निकाले और उनको मैंने स्टोर करके रखा है कि इस तरह के फीचर्स होंगे तो इट विल बी लाइक the starting stage of the tumor. If this types of features are present in the tumor, then it is a middle based tumor, and if this type of features are present, then it is a serious based tumor। तो मतलब कि जब भी हम AI की बात करते हैं कंप्यूटर विजन में, हमें 2 चीजों पे ध्यान देना होगा। वन इज फीचर on which we are targeting on, that means what are the properties on which we are going to take the decision। उन properties को मैं कहूंगी टेक्निकली यहाँ पे फीचर्स, राइट। और उसके बाद मैंने प्रॉपर्टीज ले लिया कि इन प्रॉपर्टीज में मुझे जस्टिफाई करना है, लेकिन जस्टिफाई करने के लिए मुझे एक एल्गोरिथम लिखना पड़ेगा, दैट एल्गोरिथम इज सेड टू बी क्लासिफायर। ओके, सो बेसिकली हमें जब भी AI अप्लाई करेंगे विजन बेस्ड एप्लीकेशंस में 2 चीजें बहुत इंपॉर्टेंट है। व्हाट एल्गोरिथम डिड यू अप्लाई फॉर फीचर एक्सट्रैक्शन, व्हाट एल्गोरिथम डिड यू अप्लाई फॉर क्लासिफायर, राइट। तो ये जो फीचर एक्सट्रैक्शन का प्रोसेस है, दिस कैन बी डन मैन्युअली और नॉन मैन्युअली बोथ। तो अगर फीचर एक्सपेक्टर रेडी है हमारे पास, then we can design many classifiers which we call as ML based techniques, machine learning। तो machine learning के लिए prerequisite ये है कि features ready होने चाहिए हमारे पास, right। If your features are ready, then you can go for classifier choosing, which is ML based techniques। Now ML based techniques का मतलब है कि there are n number of ML based techniques, like these are all the list of ML based techniques। Decision tree एक एल्गोरिथम है which classifies your data। नई बेस्ट क्लासिफिकेशन है AI based टेक्निक ML का। Similarly support vector machine, random forest classifier, linear regression problem, ordinary least squares regression, logistic regression, इस सारे बहुत सा PSO, ओके इस तरह से बहुत सारी एल्गोरिथम्स अवेलेबल हैं ML मतलब कि machine learning based, which are actually classifiers। मतलब इनको ऑलरेडी हमारे पास फीचर वेक्टर रेडी होना चाहिए। इफ यू हैव द फीचर वेक्टर रेडीली अवेलेबल विथ यू, देन गो फॉर द ML टेक्निक्स, राइट। देन गो फॉर द any of these ML techniques। Now any of these ML techniques, I have given some examples also here। So it means if you have the data readily with us, so I have the feature vector ready with me। अगर इस तरह का फीचर है तो क्लास जा रहा है नो, इस तरह का फीचर है तो क्लास जा रहा है नो, अगर फीचर इस तरह है तो क्लास बिलोंग कर रहा है यस। सो दैट मीन्स माय फीचर वेक्टर इज रेडी, लेकिन क्लासिफायर रेडी नहीं है मेरे पास। आई डोंट हैव द क्लासिफायर, आई हैव ओनली द डेटा कलेक्टेड। नाउ क्लासिफायर के लिए भी हमें बहुत सारी चीजें देखनी है, वेदर इट इज अ लीनियरली क्लासिफाइबल है कि नहीं है, नॉन लीनियर डेटा है तो कैसे क्लासिफाई करेंगे. सो देर आर वेरी नंबर ऑफ क्लासिफिकेशन algorithms like PCA, LDA and so on, where you can have feature reduction, feature dimensionality correction or dimensionality reduction. All these things you can apply and try to classify your data. जो भी नया सैंपल आता है, मतलब when you train your machine with your existing data, न्यू सैंपल आया न्यू ट्यूमर पेशेंट का, यहाँ पे मुझे नहीं पता कि ये लोअर क्लास को बिलोंग कर रहा है या मिडिल क्लास को बिलोंग कर रहा है या हायर ट्यूमर क्लासिफिकेशन के लिए काम क्लासिफाई कर रहा है, आई डोंट नो. So based on my trained machine, that trained machine can be designed either with a decision tree or Navy Bayes classifier, support vector machine, linear regression, logistic regression, anything else. Right? So you can use any of these algorithms. Now, how do they work? It's been shown in these slides. I don't think time would be sufficient if I discuss much on this in detail. You can go through the slides. If anybody has any queries in these particular approaches, they can drop me a mail. I will try to help them or try to resolve the challenges. So this is one such approach, decision tree. Similarly, okay, for example, if I simply see, if I assume that there is one decision tree based classifier model, ML based model designed to me, then how do I classify? So simply I take the new sample, test sample, refund ki value hai no. So I'll be first checking whether refund is yes or no. It's because a decision tree will be in the form of a tree construction. So if it is refund is no, then I'll be moving into this part. Then I'll take the marital status value. Now, if I look at this new sample, it is married. If the refund value is no and the marital status is married, then the class will be belonging to no only. That means here the class will be no. Right? So this tree has been not constructed as a magic. It's not a magic. Right? So you have lots of approaches to construct this tree out of this data. Right? And there are varied sets of trees also. It is not like only one decision tree can be constructed on the given feature set. You can construct many different trees. Right? So that means once you have the feature set with you, you can construct a decision tree, and based on that decision tree, you can take the decisions for the new samples. That is one ML based technique. Similarly, like this, you have varied number of application classifiers. One classifier is Bayes classifier, which works on the concept of probabilities. It will calculate the probability of each and every row or each and every attribute to rely in class A and to rely in class B. What is the probability of refund? अगर refund की value yes है, तो वो उसकी probability class 1 में belong करने की कितनी है और उसकी probability class 2 में belong करने की कितनी है, उसकी probability class 3 में belong करने के लिए कितनी है. So like this you can identify